All right, ladies and gentlemen, now for a little help on our last two questions of the 8-19 quiz. This is a very, very important section. You do need to completely understand how an oxidation reduction reaction works and how you can identify it. And you need to know what the term oxidation, reduction, oxidizing agent, and reducing agent. Those are terms that you need to have a working understanding of. A very easy way to identify a reaction as being oxidation reduction is you will note that there is an element on one side or on the other side, all alone, not in a compound. It can be on one side, the other side. That automatically makes it oxidation reduction, because if you remember, an oxidation reduction reaction has atoms that are oxidized or reduced. Well, your oxidation number has to change if you're an element on one side and you're in a compound on another. Because when you're an element alone, your oxidation number is always zero. When you're in a compound, you will have an oxidation number other than zero. So when we look at this reaction right here, we see compound, element, element, compound. So this can be correctly categorized as a single displacement. We have aluminum by itself, and apparently aluminum is going to join the oxygens and displace the manganese right out of that compound. Aluminum is replacing or displacing manganese. So it's a single displacement or replacement reaction. But as we mentioned, oxidation reduction reactions are a broad category of reactions. And single displacement reactions or single replacement reactions can always be categorized under the oxidation reduction umbrella. So let's take a look at assigning oxidation numbers. Because in order to determine in order to be able to identify the substance that's undergone oxidation as well as the substance that's undergone reduction, we need to see what's happening to oxidation numbers. If you remember, a trick to remembering oxidation reduction is oil rig. Oxidation is loss of electrons. Oxidation, O, is loss of control of electrons, or actually loss of actual electrons. If you lose your electrons, you lose something negative, your oxidation number is going to go up. So the substance that is oxidized, the substance that undergoes oxidation, will have its oxidation number increase because it's lost negative electrons. So let's take a look at the reaction right here. Here, aluminum is zero. It's an element by itself. Over here, we have aluminum in the compound aluminum oxide. Oxygen's -2, always, unless it's with fluorine or another oxygen in an element, O3 by itself, O2 by itself, or if it's oxygen in the peroxide ion. Here, none of those cases work. The oxygens are with the aluminum. So oxygen's electronegativity is 3, 5. It gets its -2. -2 times 3 is -6. That means the aluminums must add up to +6 because Al2O3 overall is neutral. So the aluminums must add up to +6. We have 2 aluminums. That means each aluminum is +3. So aluminum's number goes from 0 up to +3. That +3 is showing that aluminum has lost control of 3 of its electrons. Oxygen is loss. Oxidation is loss of electrons. So aluminum's been oxidized. If you have trouble remembering that oxidation, your number goes up, obviously think of reduction. Reduction means goes down. If you reduce the amount of something, it's going to go down. That means oxidation must go up. So who is reduced here? Well, manganese is with oxygens here. This is not the peroxide ion. You might be like, O2 with a metal, that's the peroxide ion there. No, no, no. Peroxide ion is almost always with family 1, alkali metals. So here we have oxygen, -2, gets its number. 2 times -2 is -4. That means the manganeses must be +4 when they start, which means that these two oxygens are each controlling 2 of manganese's electrons, since it has a higher electronegativity. -2 times 2 is -4. That's 4 electrons being controlled. So manganese starts out as 4, +4. Over here, manganese is by itself, so it's a 0. So manganese goes from +4 down to 0. That number is being lowered. That number is undergoing a reduction to it. 4 down to 0 is a reduction. Reduction means you are gaining. Reduction is gaining electrons or gaining control of electrons. Here, the manganeses are actually gaining control of electrons. All right then. If we look at this thing, we notice that this equation is not actually balanced. There should be a 3 in front of this thing right here. If you look at it, there should be a 3 right there, put nice and neatly in front of that thing. How about that? There should be a 3 right there in front of this thing. 3 manganeses, 6 oxygens. 3 times 2 is 6. 2 times 3 is 6. There we go. So we have the manganeses going from 4 down to 3. +4 down to 3, that's a reduction. Question number 10 is asking, what substance is the oxidizing agent? The key word here is substance. Substance is the key word here. The agents are the compound containing the atom that undergoes a particular process. If it's something that is by itself, well, then that particular substance by itself would be the agent. So when they're saying what substance is the oxidizing agent? Well, the substance that has the atom that's reduced is the oxidizing agent. The substance that has the atom that is oxidized is the reducing agent. The reason that is, why is it that the substance that is oxidizing agent is reduced itself? It's because if you're reduced yourself, you have to oxidize something else. If you are oxidized yourself, you have to reduce something else. So if you're oxidized yourself, you're a reducing agent. You reduce something, some other substance. If you yourself are reduced, you're the oxidizing agent because you oxidize something else. So when they're asking what's the oxidizing agent, you're looking for the thing that was reduced. In this particular reaction right here, manganese was reduced. So the substance that's the oxidizing agent is the MnO2, letter D, because the oxygen's a famous oxidizing agent, thus the term oxidizing agent. What's the substance with the oxidizing agent? Generally, it's a substance on the left side of the reaction that has oxygen in it. A lot of times, that's where the term oxidizing agent came from. So MnO2 has manganese in it. The manganese was reduced, so the MnO2 is the oxidizing agent. Substance that was reduced is the oxidizing agent. The substance that was oxidized is the reducing agent. So who's the reducing agent here? Aluminum was oxidized. It's the reducing agent. Why do they call it the reducing agent? Because the aluminum reduced something. How did it reduce it? It got rid of its electrons. Aluminum wants to get rid of 3 electrons. 4 aluminums getting rid of 3 electrons is 12 electrons getting dumped on something. When you dump your electrons on something, you're giving it negative things. If you give something that's negative, you're going to reduce it. Reduce its number. Negative is a number, negative number. So we have a total of 12 electrons getting forced onto something else. Well, each of these manganeses start out as +4. We have 3 of them. 3 manganeses at +4 mean that they would need a total of 12 electrons to end up neutral. Well, they got them. Each aluminum gave up 3. 3 times 4 is 12. Where did the manganese get its 4 electrons from? The 4 negative, where did each of these manganeses, the 3 manganeses each getting 4, where did they get those 12 electrons? They got them from the aluminum. The aluminum reduced them by giving them a total of 12 electrons for each. So that means that aluminum itself was oxidized. The substance that was oxidized, its number went up because it lost control of its electrons. When you do that, you're giving them to something else. You're reducing something else. That makes you the reducing agent. If you have additional questions on 9 and 12 or 9 and 10, don't hesitate to email me those questions. We can look at other examples of this. We can do other videos. We can have meet or whatever you need to do so that you get a better understanding. Thanks for watching.